Hello and welcome back to the channel. Today I am going to show you how to build a DIY Knobster. Now if you're not familiar with what a Knobster is, it looks like this, and it is a device created by Sim Innovations, who make Air Manager, specifically so that you can manipulate the knobs on Air Manager panels using a physical hardware control rather than trying to drag your finger around on a touchscreen, or worse, trying to manipulate it with the scroll wheel on a mouse. And if you are into the whole exterminating the mice from your cockpit thing, as I am, then this will be a useful addition to your cockpit. Now, Sim Innovations do make and sell this device themselves. You can see it here. You can see they provide it with a little case so that you could mount it somewhere on your hardware, on the side of your throttle or yoke, or somewhere on a panel. And that's certainly one way to do it. But if you do it yourself, then you can mount it any way that you want. And Sim Innovations have been kind enough to make the custom firmware for the Arduino, which is used to power the Knobster, available to everybody free of charge, as well as the specification for how you connect the rotary encoder that powers the knobs. And that means that you can do your own version, and frankly at considerably lower cost than you would be able to get it from Sim Innovations. I think that's pretty good of them to let us do that freely, and so I decided to take advantage of that and build my own. Now the process of making this is actually pretty simple, but I think it's worth stepping through the different things that you need to do, starting with the components and the wiring and how you put all of that together, then onto the Arduino itself and how you program that, and then onto plugging it into your machine, making sure it works, and integrating it into Air Manager, and finally watching it actually work in the simulator. And this video will cover all of those things. So let's first take a look at the electronic side, the parts that you need and how you put those together. So on the bench here we have all the parts that you need to make your DIY Knobster. That doesn't include a case. If you need a case, then you can find a number of different designs on thingiverse.com that you can 3D print, or get someone else to 3D print for you. Or you could make your own. It's pretty simple. The sizes are standard. Or you could laser cut some parts and assemble one. There's various different ways you could do it. I am going to put mine in a panel that I already have on the main instrument panel, so it's just a case of drilling a new hole and fitting the encoder through that hole. So this is the dual rotary encoder that we're going to use today, and this is an Elmar E37. That is a standard part that's used very often in flight sim projects. If you have a custom piece of hardware with a dual rotary encoder on it, although the knob might not be the standard knob like this, it's pretty likely that you'll be using this encoder. Other encoders are available, of course, but they tend to be lower quality, noisier, and just generally not as good as these. So the Elmar series is, I think, recognized as one of the best. And they're actually surprisingly not massively expensive. They're not cheap, let's be clear. I think I paid about £15 for this one. So as individual components, they're quite expensive, but for what they do, what they give you, they're relatively inexpensive. I got this from leobodnar.com, and they make a variety of flight sim hardware USB interfaces that are really useful. I've shown them on the channel before. I have several of them in my cockpit, and I definitely recommend those as a way to start getting into your own hardware fabrication. But they also sell regular components, or components that would be useful to flight sim enthusiasts, and this is one of those. So let's get it out of the bag. So the main difference when you buy from Bodnar as opposed to, you know, Mouser or RS or someone like that, is that they actually add this little breakout board. This doesn't come with a component by default, and that makes it a lot easier to actually wire up or plug in the thing. And they also give you this this pin out here as well. So what I'm going to do is actually solder this onto the breakout board so that I can connect jumper cables directly to this, and that means I don't have to have permanent wiring, which can be quite handy if you're trying to get in and out of small spaces. So I definitely value the addition of this breakout board, and that's why I source mine from Leonardbardner. You can get them from Leonardbardner even if you're outside the UK, because they're a UK-based company. They will ship to Europe, I believe. They ship worldwide, although I don't know how economical it is to get it shipped to the US, but definitely worth checking out if you're in the market for these kind of parts. And at least in the UK, they can get you a delivery sort of next working day, so you don't have to wait forever. You also get an optional knob kit with it. So this is the standard Elmer knob kit, and this is what you'll see for most of these applications. You could get custom knobs, or you could 3D print custom knobs, but then you would need to replicate the clamp mechanism, which is not the easiest thing to do. So I just recommend that you get the standard kit with them. Adds about another £4 to the price, I think. And that will enable me to set this up nice and easily. The second major component that you need is the Arduino Nano. So this provides the logic for the Knobster. It's basically a microcontroller on a board. And as you can see, it's quite small. It has, in this case, I think a micro USB connector. You can get them with mini USB, and I think even maybe USB-C from different manufacturers. And Arduino is an open standard, so many different manufacturers make these boards. This one happens to be from Elegoo, who are probably better known for making 3D printers and also laser cutters. I bought one of their laser cutters, although I did send it back and get an X tool for reasons I'll talk about in my laser cutter video series coming real soon now. It has to be an Arduino Nano, if you like, classic Arduino Nano. There is a new product called the Arduino Nano Every. Don't make the mistake that I did of buying one of those first, because it doesn't work with the Knobster firmware from Sim Innovations, and I don't know if they're planning on supporting the Nano Every at some point, but they definitely don't right now at the time of making this video, so you will need a regular Nano. Specifically, you're going to want the it's not on the back of the box here, is it? No, it's I'll flash up the number of the chipset that you want and the processor that you want on the screen now. So you want those. You don't want the Nano Every, which is a different one, which I'll also flash on the screen. That one you can't use, so look out for those when you're buying. Make sure you get a proper Nano. Once you have got a proper Nano, then it's pretty easy to connect the encoder to it. There's a chart on the Sim Innovations website, which I'll link to in the video notes below, and that will tell you which pins to connect which outputs from the encoder to. And then to help you to do that, again, you've got this this breakout, which you can just solder onto the Arduino. There's one for each side. I'm not using any of the pins on this side, so I'm just going to solder on this side, and then I can use a ribbon cable to connect between the two of them. You could obviously just solder the connections directly and permanently. However, I find soldering at this scale pretty fiddly, and also I'd like the ability to connect and disconnect, so I'm going to use a jumper cable, ribbon cable in this case. Got this from Elegoo, again, no particular reason why, it just happened to be available quickly on Amazon, and it comes with 3 different ribbon cables. This is the one that I want, which is female to female, so that's what I'm using. It also comes with a male to male and a male to female, in case you have need of those, and these will come in handy for other projects, so I'm definitely going to keep them. And then this itself, we only need 6 pins on this project, so I'm just going to go from the right here, and luckily ground is one of the outside pins, and black is traditionally ground, so that's good. So 1, 2, 3, 4, 5, 6. So basically, if I just pull off this part of the ribbon cable, that gives me a 6-pin cable, which is what I'm going to need to connect it to my PC later on. So what I'm going to do now is solder these parts up, and then we'll connect them together with the ribbon cable, and we'll connect it to the PC, and we'll have a look and see if we can't make this thing work. So let's get on with that. So when I took a closer look at the encoder, it turns out that this board is not actually soldered on, which is not normal. It normally comes soldered. So I'm assuming that's a production error on the Bodnar end, because I think you can get these separately so you can solder them on yourself to encoders that you bought elsewhere, but this should actually be fully soldered. So I need to fix that first before I can go ahead and solder on the breakout. So let's do that. And those all look okay. Alright, so now I can get on with actually soldering on this bit, which is the bit I wanted to solder on. And I'm going to put it on this way around. So when I turn this upside down, of course, what's going to happen is it'll fall straight out. So I need some kind of thing to hold it in place. So I'm going to use a little bit of just painter's tape. And I find this works reasonably well. We need quite a lot of it because I want to loop round. So let's just put that in there like we want it. I'm just going to cover up one side of it so I've got access to the other side for soldering. So I just need to... Looks nice and straight. So now I'll just solder the 2 pins here, and then the rest of it should stay in place quite happily. Okay. So now we just got to do the same with the Arduino Nano, and we'll be ready to connect them up. Okay, well that'll work. I'm just going to tidy it up a little bit more though. I think possibly the application of a bit of flux might help with this, but too late for that now. So, now we have both components wired, soldered up. Let's proceed to wire them up. Right, let's make ourselves a cable. So we want 6 pins. So 1, 2, 3, 4, 5, and 6. Then I should just be able to pull that away from the rest of the bundle. And that gives us our 6-pin cable. Now we need to refer to the pin out. So we're going from the ground pin here through to 2, 3, 4, 5, and 6. So let's just do it in order. That's ground there. Then ground. Then D2, D3, D4, oops, come on, D4, D5, and D6. There you go, so they're all on. And then we need to just work out what the other side is going to look like. So, if I refer to my handy chart, you can see on the base of the encoder here on the breakout board, we've got so a ground common, which is here, and then we've got the button line. So when you push the encoder, the common and the button are connected, and then you've got your outer and inner encoder part. So this is the outer part, the small bit, and this is the inner part, the top bit. And then each of those has an A and a B signal line, and you need to make sure you get those in the right order, or else things will not work at all. So the black is the common, so that will go onto this one. Then we need the inner B. Inner B is D5. So look for the colour that's on D5, and that is the blue. So the blue goes next. I might just give myself a little bit more clearance on these wires. Just strip them back a little bit. There you go. So blue goes to inner B. And we need inner A, which is D4. D4 is the purple wire. So D4 goes on here. And then we need outer B, which is D2. And D2 is the white wire. And then we need the outer A, sorry, inner A rather. No, outer A, which is D3. D3 is the grey cable, which is here. Let's just get that out of its little tangle. Put it on there, and then obviously the last one, which is the green, is D6, which is the button line. So that's your wiring. That should work. So now we need to connect it to the PC and test it out. So let's do that. So we're on the Sim PC here, and I've connected the Nano to the computer, and I've installed the knob, etc. And so in order to check that it's actually connected and working, the first thing you should do is go and look in Device Manager. And in Device Manager, you want to find the Ports, COM and LPT section and open that up, and you should see something like this USB serial CH340 on COM5. Now, I installed a driver from Elegoo for this. Windows probably would recognize it on its own, but I thought it was better to have the driver straight from the manufacturer, and so that is the string that I'm getting. You see I have some other USB serial devices connected, so it would be easy to get confused, but with the CH340, which is the microcontroller number, I know that that is the right device. And I want to take note of the COM port that it's on, which is COM5. The next step is then to open Air Manager, and we have it open here. And on the bar at the top there, you can see it says Flash. So I'm going to click that. I get a dialog, which I'm just going to bring into view for you. And it says, okay, select your board. Now, you can see it's listing a variety of different boards, but I said earlier that only the Arduino Nano will actually work. That is true. If you select any of these other boards, you will not get the little checkbox that says Flash as a Knobster. So for example, if I click on the Mega 2560 and go next, I don't get any kind of checkbox, whereas if I go to Arduino Nano and next, then I do get the Flash as Knobster checkbox. So I'm going to pick the COM port that it's on, which is COM5. I'm going to say Flash as Knobster, and I'm picking channel A because I'm only going to have one Arduino Nano connected to this machine. If you had more than one, then you could put it on B, C, D, and so on and so forth, and you could have multiple Knobsters all working at the same time. And now I click Flash, and we'll see what happens. Okay, progress bar means it's working. And when it's done, then Air Manager will start looking for the new Knobster. So if we look down at the bottom on the left there, you see it's searching on port COM5, and in a few moments it should pop up with Knobster A. There you go, Knobster A. All right. So now we can test it. There are some settings here that you can change. I recommend you leave them alone for now. Most rotary encoders work on 2 detents per pulse, but you might want to consider turning that down to 1 or up to 4, which you can do for either, and experiment depending on the results that you get. But most encoders are fine with 2. So I have the 737 center panel already set up on my center monitor. So I will take you over there. So this is the center panel. And I've actually put a COM radio on there, which doesn't normally go there, just so I can demonstrate this. And then I have the 737 NG running in the sim itself. Now, in order to get anything working, I need to get power on in the aircraft, so I'm going to do that now, and then bring you back when I'm ready. Okay, so we've got power to the aircraft and the avionics are up and running, which means that the power to the radios is also up and running. So back here on the center screen, we can see that the COM radio instrument is now alive and connected to the sim. So let's go back over to this screen, and you can see that in the actual panel itself I need to do something else, which is I need to go into the Knobster setting for the panel and say Knobster A. If I don't do that, it's not going to work. And once that's enabled, we should now be able to test it out. So let's have a look at the actual physical setup in the cockpit. So this is the setup in the cockpit, and if we look down here, you can see I've actually got a knob labeled Knobster, and I already had the other encoder, the frequency select there, on this panel in the cockpit. I've had that for a long time. That's connected to a Leo Bodnar card. My initial thought was that I could somehow make this work both ways by having some kind of mode switch, and I played about with that and discovered that it doesn't work for reasons that have to do with how rotary encoders actually work that I won't go into here, but I ended up putting in the second knob, and that works specifically for the Knobster. So in terms of how you make it work, what you have to do is touch the control that you actually want to adjust with the Knobster. So let's go with the tuning wheel. Now it turns yellow. It'll only do that if there's a Knobster connected, and that indicates that it's focused for the Knobster. If I come out so you can actually see both the instrument and the knob, then when I turn the outer encoder to the right, then the left frequency, the left part of the frequency, 124, that should go up by 1, and it does. And again, if I turn it anti-clockwise, it goes down, and the inner adjusts the right-hand side of the frequency. So you can see it's working. You can also adjust this knob, the HF sense, and then in this case the inner and the outer are actually doing the same thing. So it adapts to which button you actually pressed and how that's programmed. Now, not every single, sorry, I lost the focus there. Not every single button can be manipulated that way, but pretty much everything that's rotary should be able to be used like that. So all you've got to do is touch it, and if it goes yellow, then yes, it can. So this is a brightness control. This, on the other hand, cannot. So you can see it just moves one way or the other. That's just a rotary switch. So that's what you really need to do. You can go hunting through your panels for all of the things that will go yellow and can be adjusted. And that, in a nutshell, is how the Knobster works. As I mentioned, you can have more than one Knobster connected to an instance of Air Manager. I think you can go A through P, so quite a few of them. And if you have, for example, a large cockpit setup with lots of different screens with Air Manager panels on, and you would like to use a knob that is approximate to the screen that you are using, then you can have an additional Knobster or 2 or 3 in your cockpit setup and choose which one you want to use on a per panel basis just by adjusting this setting here. But do remember that if you don't deliberately go into each panel and say Knobster enabled and pick the Knobster, then the Knobster will not work with that panel and the rotary control will not go yellow when you touch it. So that's it. That's the whole process of making, setting up and using a DIY Knobster in your cockpit. And if, like me, you're using Air Manager and you have a lot of panels with dials, rotary switches and knobs on them, you may find this a worthwhile upgrade, something which allows you to use them quite a bit more easily. It's pretty easy to do, took me about a morning, doesn't require more than basic electronics knowledge. It's relatively inexpensive, certainly less expensive than buying directly from Sim Innovations, and it's something I'd recommend that you try if you are interested in giving it a go. With all that said, this is the end of the video, so if you liked it, please click the like button. If you disliked it, it would help me to know, so please click the dislike button. If you have any questions or comments, leave them in the comments below, and I try and answer questions as quickly as I can. If you'd like to subscribe to the channel, I would welcome that, but please do click the little bell icon because the schedule here can be somewhat erratic and therefore you will know when I publish a new video. Otherwise, I will say thank you for watching and I look forward to seeing you back on the channel very soon.